Joel, welcome back to the show.
Yeah, thanks for having me back.
So, as we were just talking before I hit the record button, it feels like when we did this, it was almost a lifetime ago.
Yeah.
Especially the last few years feels like every day feels like a month almost, trying to keep track of
Yeah.
everything. But, you know, you were doing something very different the last time we talked. You were at Mount Sinai,
Uh-huh.
and now you're, at Tempus. And so let's start there. Like,
Sure.
why the switch and
Yeah.
what are you doing?
Yeah, I think like many people at Tempus, I didn't expect to be at Tempus. So I've been here about a little over a year and a half now at Tempus, and I was approached by Eric Lefkofsky, the founder of Tempus, when I was at Mount Sinai, and things were going great at Mount Sinai. I was fully tenured. I had tons of grant funding, cool projects, even startups spinning out of the lab. So I thought, I definitely wasn't looking for a job at all, and I hadn't really heard of Tempus at the time. I just knew they were kind of out there, and I somewhat heard of them. And he approached me about a job, and I'm like, yeah, I'm not looking, And I know people at Guardant, I know people at all the sort of big Freenome and precision medicine companies. I thought, well, if I was going to go, why would I go to Tempus? And like I know everybody else and these other companies. So he's like, just come to Chicago, talk to me and see what's going on. And then I looked at the website and I'm like, how the heck is this company worth $3 billion? They're $3 billion, $8 billion valuation now. And I'm like, I was, to be honest, a bit arrogant because I'm thinking, I know everybody in this field and I don't know what these guys are doing. I was sort of miffed, which was a little arrogant to say that. But it's like, sort of like, how could a precision medicine company get to $3 billion without me knowing about it? So at that point, it was almost curiosity at that point that brought me into their headquarters. Obviously back when we could fly and travel. So I went in there and I'm like, well, I got some collaborators at Northwestern anyway, I got to meet with, and I'll just, I'll go see what this tech dude wants. And I was even telling my wife before I left, I'm like, oh, these tech guys, like they always have the worst healthcare ideas. Like they have the worst healthcare ideas. so I'm like, but that being said, I went and visited Eric at Tempus headquarters. I was completely blown away. It was a company like nothing I'd ever seen before, and I can get into some specifics on why Tempus was different. But at a high level, it was really the first company. So my background, I'm very much a systems guy, right? I like to understand everything from a multiple systems perspective, right? If in the molecular world, that means I'm a systems biology guy. I want proteomics, I want genomics, I want the whole thing. Yep. So when I would look at other companies that were doing targeted DNA panels, I'm like, well, what fun is that? I know there's a good reason why people do that because of reimbursement and all that kind of stuff. But it's like, what am I going to learn from DNA? Nothing. So it was my bias. And Tempus was the first precision medicine company operating at scale I saw that was totally committed to a multi-scale, multimodal data philosophy, which I had never seen before, and was totally committed to this concept that I think you and I get excited about, which is a diagnostics company that was first and foremost a data company, first and foremost. Right. Now, there's a lot of diagnostic companies that paid lip service to being data companies, but when it came down to it, they were all about volumes and margins of their tests, right? Tempus was the first one that was authentically and seriously and in a big way committed to being a data company at first. So I was totally blown away, and at first, said, there's no way I'm leaving my great job here in Mount Sinai. And then I kept thinking about it, and I thought, holy cow, if these guys are successful, this is going to be massive. I mean, this is going to be bigger than anything I could do at any single academic institution. This is going to be world changing. So anyway, that was a lengthy explanation of why I joined Tempus. It just wouldn't get out of my brain.
Well, it's interesting because I remember when you told me, I was like, what?
Yeah.
Huh?
Yeah.
Like I was adding up what you were adding up, like all the different things you're doing. And I'm like, he went there. I'm like,
yeah.
I almost was thinking, can I buy stock? If he's going there, I should buy stock. So, but what was, Eric, before he did, Tempus obviously did Groupon, and
Hmm.
he's financially successful, I could
Yeah,
probably say. But
yeah.
what was his motivation?
The origin story of Tempus is that Eric's wife had gotten breast cancer, and yeah, someone of great means, of course, was able to have her seen by all the best, literally all the top 10 breast cancer doctors in the country. And what he noticed, being he's if you get to know him, he's a very rational, logical guy, very data driven guy. Um, he noticed very quickly that, first of all, none of the doctors agreed, that data wasn't informing her care, and got a real personal look at sort of the dysfunction, I guess, or let's say missed opportunities to use data
Right.
in healthcare that we see, you and I see. And he decided to do something about it. There's a lot of really admirable things, that about his personal involvement in Tempus, that drew me there. One is he's all in. I mean, he is all in, 1,000% of his attention is focused on the company. He's got a venture capital firm. He's got Groupon still is in existence, and he is he is in a huge way. He's, I think every time I've been to the office, I think he's the first one there in the morning. It's just like, in some ways he's sort of like the general that rides the first horse in the battle, on this thing. And not only was he in a big way financially, he put a huge amount of his own money into the endeavor, but his personal investment is he's fanatical about Tempus, which was
Well,
interesting.
I'm convinced that when you want to change the world, if you're not
Yeah,
fanatical,
yeah,
it's not going to happen. Right? You have to believe it more than anybody else believes it to make it come true.
yeah,
Um,
yeah. One of my
but
favorite stories, I'll share quick though on
go.
that note, and then I'll switch. Was I remember one time we were having a discussion. I can't remember what it was about a flow cell. It was just after I joined, a flow cell failing or something like that, and on the sequencer. And Eric, I think, had asked for which flow cells failed, and I had walked by his office at Tempus, and the bitmap, the images of the flow cells were up on his computer, and he was like staring at them intently. I have no idea if he even knew what he was looking at. I mean, he does now for sure, but the point was, it was just shocking to me because I'm like, here's the CEO, billionaire CEO of this company, and he's looking at the pixel by pixel at these flow cell images, trying to figure out why they failed. And I thought that was unbelievable, unbelievable.
Well,
So no detail was too small. So
no, I think, you have to be passionate, get involved, and want to,
yeah,
I mean, at some point you're at scale and you have to sort of start
yes,
trusting the
yes,
people around you.
yeah, yeah, of
But
course, yeah,
but in the beginning, I think you have to fully be committed. And if the,
yeah,
and everybody has to be going with you.
yeah, oh yeah,
Uh, um,
yeah,
so, and I totally agree on the whole data-driven part. I mean, I
mm,
have given so many talks, especially with good friend of mine, Jennifer Carter, who was the former CEO of N of One, where
mhm,
there's a bunch of doctors where the genomic data is saying one thing and they decide to do another, which
mhm,
boggles my mind of why you would do
mhm,
that, because most of the
yeah,
time it doesn't work.
mhm,
Um, but so you guys are at the forefront of genomic data, and I'm sort of imparting words of saying you're trying to get faster real-time patient care decisions and
mhm.
help physicians make better decisions. Is that am I summarizing the business?
Yeah, yeah, that's it. At a high level, it's obviously to deploy precision medicine at scale. So one of the things we say we're doing at Tempus is building all the boring plumbing that nobody wants to build
Right.
to actually deliver precision medicine at scale, which includes so we ingest clinical records for the patients, which because we contextualize the reports with the clinical data that we get from the individual patients. So, but we work with everything from rural community hospitals to sophisticated academic medical centers. So we have this part of our machine is we have this interface that can take everything from a direct pull from a Cerner cloud instance all the way to literally people shipping paper to Tempus. But basically we built that data abstraction API, if you will, that can take either paper or cloud. And it was expensive. It required a lot of people, and it cleans up the data, but it just somebody had to do that. Like someone had to build that the boring plumbing to do that, and we did it. So
Well, flat
is
out,
one.
I think you know, what I've heard is Flatiron has a bunch of people in the back end, like putting things in context, right?
Hmm.
Yesterday
Hmm.
versus tomorrow versus, you know,
Yep.
trying to get context, which NLP is not very good at. And
Correct.
I got to imagine that Foundation might be doing some of the same sort of stuff. No, not
Not
as
really.
much.
No, they're not as much on the clinical data. They're very much focused on the molecular data. The difference, though, between Flatiron and Tempus, though, is that Flatiron bought the EHR, you know, which the data was being
Right.
collected in, so they own that. We take everything, like I said, from manila folders to Cerner to, you know, Epic to, like, that was the challenge. That's what makes Tempus totally different, in that, you know, we didn't own that EHR, so it was a bigger challenge. But we also have humans that check all the data, because as you mentioned, NLP isn't imperfect. But but the real business, though, if I could make a point, though, is developing smart diagnostics, because the principle being, you know, we all want to bring AI, let's say, to healthcare. One way to do that is to put AI into the EHR, which doesn't seem like it's going to happen anytime soon. Like, we have a hard, you know, obviously we barely can get logistic regressions to run inside Epic. So I don't know. I don't think we're going to. I shouldn't pick on Epic alone, but, you know, it doesn't seem like very sophisticated AI is coming to the EHR anytime soon. Plus, there's sort of a small number of players you have to deal with, you know, to have control over that environment. So that's challenging. You could try to bring the doctors to AI, which doesn't work very well. A lot of companies have failed because they say, oh, well, we'll have this beautiful AI machine, this beautiful interface. If the doctors would just leave their, you know, standard workflows and just come over to our
Right.
obviously better system, that fails, like, you know, 99% of the time, right? Because doctors don't want to change, or physicians don't want to change their workflows. So the idea behind Tempus was, well, physicians interact with lab tests all day long. So one step at bringing AI, or Trojan horse, if you will, is to, like, make the lab tests themselves smarter. So a real simple example is on our cancer testing is when because we pull in the clinical data on that patient and the sequencing data. Here's a real simple example of something that Tempus can do with a smart test that other people can't, which is, if they have a DNA mutation that suggests the patient should go on a certain drug, but we know from their actual clinical records that they tried that drug and failed it, we will dynamically change the report, you know, to not suggest that drug, or gray it out, or whatever, depending on the version of a report. That's like a brain dead, you know, simple example, but most companies can't do that because they're not able to rapidly pull in and structure the patient's clinical data and contextualize the molecular data or the test result with that specific patient's information. So that's the Tempus approach there.
Well, not to digress, but I've always said in my talks, I believe that if anything breaks or will break healthcare, it's the EMR systems being
Yeah.
completely, you know, I mean,
Yeah.
they're just not where they need to be, considering how fast we want to go to the
Hmm.
next level of healthcare, right? If we were a
Correct.
tech company, it would have been rewritten, you know, 15 times by
Yeah.
now to get us to where we need to go. Um,
Yeah. Totally.
but you guys are not, you know, it's not just working on, like, you know, you're looking at DNA, you're looking at RNA,
Yeah.
you're looking at a whole host of omics
Hmm.
to
Hmm.
help drive positive outcome. I mean, are there concrete examples that you might give in
Yep.
how this is being used, and why, you know, why Tempus is compared
Hmm.
to everybody else where it is,
Yep.
I would say.
Yeah, absolutely. So, you know, one of the things that we think about when we get a sample in the door is how much sort of multi-scale data can we generate on the sample without being totally insane, right? So it's like, meaning with still being sustainable, let's say. So, so I'll give you. So what happens today when let's say, so by the way, we're expanding outside of cancer, but focusing on cancer for the meantime. When a tumor section comes in to our current lab, so not only do we get sort of the deep targeted DNA sequencing, we also get normal blood as part of that. So we can do tumor normal. A lot of companies don't even do tumor normal. But then, and this is one of the things that really caught my attention, was we generate full transcriptome on every patient that comes in the door. I mean, that's nuts. I mean, that was nuts that they just decided to do that as a default on every patient that came. That's like, you know, $800 in extra cost that's not going to be reimbursed. And you know, and even clinicians can barely, you know, wrap their heads around RNA today. I mean, they just have a super hard time with RNA. I mean, they like DNA because like the variant's there or it's not,
Right.
and the drug gets prescribed or not. But RNA is this, analog, probabilistic sort of that dynamic measure that gives you all kinds of different types of interpretation that's difficult. But the fact that they committed to that from day one was nuts. So then we also have our own pathology lab. So we
Hmm.
actually digitize, we section and stain and digitize all the tumor sections. So we have high quality imaging. And then we pull in the structured clinical data, of course, and then we have an organoid lab actually inside Tempus. So we tried to build a patient specific organoid from every patient we can, and bank that
Jesus.
for future screening. So we have a huge number of organoids where we have not only the organoid stored and ability to re-expand that, but then the patient's actual in vivo clinical data, molecular data, and you can start to do things like, hey, where if we see this pathway in the organoid, it means we're going to see this pathway in the real patient, and all that kind of stuff. So another interesting thing about Tempus is we have this new business unit called Algos, and this is something that sounds really obvious when you point it out and you wonder why nobody else did it. But we go to market with the broadest possible assay. So in a traditional like biomarker discovery, you would say, I want to try to find a biomarker of people who respond well to radiotherapy or something like that, prostate radiotherapy or something like that. So I'm going to start with, people would start with their full transcriptome. And then let's say you find a 10 gene signature that predicts who's going to respond well to radiation therapy.
Right.
Then the typical diagnostic company would say, okay, now let's take this 10 gene signature, let's implement it at nanostring or PCR or some point of care platform, and then go to market with that. And Tempus says, well, screw it. Let's go to market with the full transcriptome as our default assay, because then that allows us to digitally layer signatures on top of it. And by default, everybody, so we measure transcriptome now, and maybe 5 years from now, we find a new signature for drug response. We don't have to remeasure everybody. We just run it digitally on top of the signature.
That was one of the, I remember when we were talking about this years ago, I was like, that's what you would want to do. That's why you'd want the data, right? So you want all of this data so that as time goes on, you don't have to go back and get it again. You've got it and you just look at it.
Yeah.
It's almost like, I think about it like topology. I mean, at some point you take the first scan and you start layering things on top to get a better idea of what is there over time, because the technology, your insight becomes better over time. Some new piece of information comes in, let me go back and look at this again, which is interesting. So you guys do that, and then the recommendation is a targeted therapy. I mean, I haven't seen any of the reports, so I'm sort of guessing along here.
We've got a great report that summarizes the patient's clinical history and all the stuff you sort of expect, and then it offers various recommendations also about, of course, clinical trials. So the other thing we have is a huge clinical trial network, which I haven't mentioned yet, national clinical trial network where we can spin up trials and match patients to trials. That's owned and operated by Tempus. But we can, so it takes the DNA information, and RNA information, and synthesizes recommendations based, it's going to be up to the doctor, of course. Some doctors only like to look at the DNA. Some people like to see where does the DNA and the RNA corroborate each other. Is there a PI3 kinase mutation plus activation or deactivation of a PI3 kinase pathway or something like that? And so we present all that information in a pretty digestible way.
So 2 questions. A, does the patient ever get something to look at? And B, have you done any stats on success, right, of recommendation and so forth?
Yeah, we've published some. We have published some papers. We had a paper in Nature Biotech and a couple others that sort of show the value of this additional information, and continue to publish papers. But no, we've been primarily on the cancer side, primarily physician facing, and physicians can of course give their reports to the patients, but we've been physician facing. In other disease areas like neuropsych, which we've gotten into, we do have a patient facing digital app that is being tested right now to go more directly to patients, but not yet in cancer. And COVID as well, we have a patient facing app. So, but that obviously will be a bigger part of all the disease areas.
So now where, I mean, you guys are getting, you have agreements with tons of institutions coming in. I mean, you and I were
Mhm.
at one point sort of throwing this idea of having enough data where you're at that escape velocity of
Mhm. Mhm.
it sort of stops making sense to go someplace else because the Encyclopedia
Yes.
Britannica is in
Yes.
one place. So
Yeah.
where are you guys on that journey?
Yeah, I think we're, it depends, you could argue it, but I think we're basically approaching escape velocity at this point, where if you look at the trajectory of our data, and I don't have the exact numbers handy, but it's a steep line in terms of the number of samples we sequence. I think it's close to 200,000 samples last year or something like that. But our RNA, for example, our RNA database alone is, I mean, the Cancer Genome Atlas looks like a little baby toy data set, compared to Tempus's internal data set, and that's of course a massive, I don't know if it's a multi-billion-dollar, but it's a massive internet effort among academics. It's a great effort, by the way. I'm not knocking the Cancer Genome Atlas, but by comparison, it just Tempus is just able to eclipse that, like you wouldn't believe, and then also have much richer clinical data associated with those samples and have continuous updates of that data. Or something like the Cancer Genome Atlas is like this frozen thing that gets updated by an academic consortia every year,
Right.
through typical. So even when we look at the Cancer Genome Atlas, which again I think was a worthwhile investment and remains a worthwhile investment, but if you just compare those, the growth trajectories and the density and quality of that data side by side, Tempus is just a rocket ship compared to that data sets like that, which used to be like, even pharma would rely on the Cancer Genome Atlas as their sort of discovery data set, but now you'd be kind of insane not to use Tempus. It's just so much bigger.
So that brings me to that next question, right? So we've got these patient samples, we've got
Yeah.
clinical data.
Mhm.
You make a recommendation. You can actually recommend a clinical trial.
Yes. Yes.
And but now the next step comes to me and says, well, but if I have all those pieces of information, shouldn't I be also looking at drug discovery?
Yeah. So, and quick on the trial site, it's worth, I'd like to point out because we're really proud of this. So we have this thing called the Time Trial Network. It's a national network of, I think it's 2,000 oncologists around the country on a common rate sheet, a common IRB. And the whole idea was when we match a patient, so instead of a drug company going to, say, an AMC like, Dana-Farber or something, which of course is a great institution, and saying, hey, we want to run our XYZ drug trial with you, and all the patients will have to either fly here or drive here, every couple months, or hopefully if you don't have all the patients here locally. We created this national network and the idea was rapid site activation of trials. So if a pharma is looking for a certain type of pancreatic cancer patient subset, and we match that patient in Tahlequah, Oklahoma, or nearby, or something like that, just picking a
Right.
random city that, instead of that person driving into the AMC Academic Medical Center that has the trial or CRO, we spin up a trial as close as possible to where that patient lives at one of our partner, whether it's community hospital or
Mm-hmm.
something like that. At the end of the year, don't quote me on this, I think we had we went from like a patient match to first dose in patient in something like less than 10 days or something like that, because we rapidly activate a single patient trial site
Oh,
wherever
that's
that patient
cool.
lives. It's pretty cool. So it's sort of like a whole ecosystem, right? So it's not only are we sequencing the patients and finding them who are eligible, we also have the trial site integrated into our
It's
platform. So
it's interesting. I always wonder like how aware are patients that some of these things are out there when they need it, right? As opposed to the way that
yes,
you and I both know the way the system runs, which is, oh, come
yes,
here, right? So that we can make the dollars as opposed to what's really going to be the best for the patient.
yeah, absolutely. And you had asked me a second question that I totally forgot now because I distracted towards
The
the
drug
trials. But
discovery side of it,
yeah,
just
so
making that
so
connection at some point of,
yeah, so it's super valuable data um, for drug discovery, and that is part of the value proposition of Tempus, of course, to our pharma partners who want to develop therapeutics. So part of Tempus's business is to partner with pharmaceutical companies and assist them in their discovery or biomarker efforts through Tempus's data and platforms. And we have some back-end platform technologies for interrogating our data. There's a platform called Lens for interrogating our data. That is pretty interesting. And then, we have a business called Alpha, which is about spinning out joint ventures around therapeutic discovery from Tempus's data. So
okay, so that's how if you identify
yeah.
something, you're willing to sort of spin it out at that point and see it come to life.
Yeah, and so it's partnering with pharma or partnering with a joint venture that we're involved in around the data. But per se, we don't do the drug discovery internally on the data. So it's
so here's it. You and I, love the data, love the AI, machine learning. So what gets you super excited? Where do you see the biggest applications of the AI and machine learning that's really moving the needle forward? Where do you see the biggest opportunities?
Yeah, in no particular order. So a lot of interesting things can be done with machine learning when you have not necessarily orthogonal, but multi-scale data on the same samples, right? So I'll give you a concrete example is we have a large histogenomics, we call it, program that our AI data science team is working on, where of course if we have rich RNA sequencing and rich DNA sequencing plus digital pathology on slides and samples, we can start doing things like calling PD-L1 status directly from an H&E stain via deep learning instead of actually sequencing a patient, because sequencing is great, but imagine if you could call the critical markers for a trial via an H&E stain and deep learning in rural Louisiana, where maybe or something like that, where people don't want to pay for sequencing, or you just want to be much more capital efficient. So once we start collecting all these different dimensions of data, we can start predicting across all these different dimensions, right? So what in the rich sequencing data can we predict from images, for example, which is really interesting, because then that costs nothing practically, right? So
Right.
it's but the key is upfront, you have to collect those cohesive or coherent data sets of multiple dimensions to train. Once you've trained, it's super valuable.
It's interesting because I was having a conversation earlier today about spatial resolution of single cell, but actually looking at the genomics inside the cell, the expression patterns, and looking at that based on geography, let's call it that, so everybody understands it. But very cool how you could see individual cells lighting up versus the other cells around them, which would give you an indication of what's being activated, how it's influencing the cells around it, et cetera.
Yeah, absolutely. And that's an area we're exploring within Tempus, of course, is related to the histogenomics I mentioned, is if we start doing single cell and spatial transcriptomics on tumor cells plus rich imaging, at some point we're going to build up a data set that will give us deep molecular insights from the images alone, once we've built up the single cell and spatial transcriptomics and that accompany those images. So that's one, it's a really useful practical application of AI. Another one that's interesting for us is just getting additional insights out of existing data, which is something I've always enjoyed. But a concrete example is we have a big partnership with Geisinger, where we developed a deep learning model that runs on ECG traces. ECG traces are collected for elective surgeries, for physicals. And we're not the only ones necessarily exploring this, but a lot of people are using deep learning models to see if because ECG trace you could consider an image basically, right? And so people are using it episodically to see, is there something, that subtle pattern that's not being detected in the episode of care? But we're actually trying to predict things that will happen in the future, and we've published some papers on this. But so we're taking a single ECG trace and we're saying, are there hidden signals basically in this ECG trace that will predict if someone's going to get future AFib, future stroke, future AC coronary syndrome? And we have a very large data set with Geisinger that we've in partnership, and it's just amazing, like the 1 year, 3 year future events you can predict from a single snapshot of an ECG. Yeah, there you go, cardia.
I have my little monitor here, and I tend to do it every day just to get some longitudinal data.
LiveCore is a great device. So there's a couple of really interesting applications of that. One is, from a population health standpoint, just going through all of the ECGs that have been collected, and you can triage people in the high risk, low risk groups and manage them. But it's also interesting for clinical trials, because if you can predict things in the future from an ECG trace, say for like an anticoagulation trial, you can enrich that trial population for events and things like that from a fairly cheap, standard device. So I'm interested in, the ability of ML and AI to get squeeze additional information and utility out of these sort of everyday, things that are measured routinely.
Yeah, and I think that, I mean, it's, whenever I've seen it, we've always gone from a complicated measurement to figuring
Yeah.
out easier modalities to sort of
Yes.
identify that information from. We just didn't have maybe the power per se to
Yes.
get it in the first place.
Mm-hmm.
So, okay, you guys are in oncology. Now you're moving
Yeah.
out to cardiology, and I
Yeah.
think infectious disease, and
Mm-hmm.
do I dare say neurology, depression, and things
Yeah.
like that. So,
Yes, exactly.
so why? Like,
Yeah.
why wouldn't you
Yeah.
just go deep and, crush the space in that one area? Why?
Yeah.
What?
It's interesting. I feel like, we are doing fairly well in oncology, but this goes back to why I joined Tempus, which is I had seen, or I saw that they built this totally integrated. I always joke that Tempus is like 4 different companies, and it's like, oh, it's like Flatiron plus Foundation plus, and we don't like to compare ourselves to these companies, but like this is early on when I was, because we're actually not like those companies, which I'll explain in a second. But I was like, on the outset, it sounds sort of crazy to say, well, we're like 6 companies in one. But the difference was it was built that way from the ground up in an integrated, platform, vertically integrated platform, and that's what makes it powerful. It requires a lot of capital to do that up front, but the vision was pretty interesting. So they built this sort of vertically integrated, very powerful machine to tackle cancer in this like multimodal, comprehensive way. But they were smart, and then they built it in a fairly abstract,
Yeah.
way, such that it could be repurposed for other diseases. And from day one, that was always the intention. And to me, that was amazing, because I'm thinking, well, geez, a company that just tackles cancer alone with this approach is a massive company. Putting on my venture advisor hat, it's like, well, geez, this is huge, because this is like this company plus that company all wrapped into one nice, seamless package. It's huge. But then I thought, well, if they replicate that success they're having, clearly going to have in cancer in just one other major disease area, that is an unprecedented precision medicine company in history. No company would have done what Tempus has done in cancer in a whole other, disease area, in terms of ushering in this like very large scale multimodal approach that's with clinical tests in the market and things like that. So I was like, I got to join this. This is nuts.
Well, it's interesting that you say that, right? I keep trying to explain to people, and I guess one of the examples that I've been using lately is something like Ant Financial, right? Where how they started in one area and were able to broaden based on some, very simple, capabilities. And now it's 10,000 people managing 1.2 billion customers.
Yeah.
Right? You don't do that because of a personal touch. You have to have automation.
Yes.
To tackle that. And I know that you guys have like your robotic systems for sequencing and so I gotta believe that
I'm gonna turn off an air cleaner here for a second. It's making a lot of noise. I apologize.
Yeah.
Sorry about that. Hope we can edit that out. Yeah. So
it's I have to believe that thing doesn't, I always tell people, it doesn't care what it ingests, right? The analytics on the back end may need to be adjusted accordingly, but that's the power of this data approach as opposed to the way we've done it historically.
Absolutely. And the way I always describe it, I'm not sure if everybody at Tempus loves this analogy, but I think it's a very accurate analogy, which is what I saw, and we're doing this. So we built this, very sophisticated, vertically integrated infrastructure that connects like sequencers to clinical and back, plus data abstraction and clinical data structuring. So we built that machine and sort of dog fooded it ourselves on cancer and other things, and we continue to sort of dog food it and use it ourselves. But eventually, the goal of Tempus is to open this platform up to other people. So what I saw early on was that, wow, Tempus has the chance to become the AWS of precision medicine, basically. Like like we're building all this boring plumbing and we're connecting hospitals. We're building this, like I mentioned, this API of data abstraction that can connect everything from cloud-based EHRs to paper, and everything in
Right.
between. So at some point we want to open that, and we're actually beginning, some partnerships where we're opening up Tempus's platform, because if we've invested $1 billion in that plumbing, then the beauty is, you shouldn't, as a startup, you don't have to do that now, just like AWS. It's like now, three guys in a garage can get out their credit card and start Stripe or Shopify or or whatever the next big company is. And that was always been the aspiration of Tempus, is not only to build this for ourselves, but to build it as an enabling, platform for other people who would want to deploy precision medicine at scale, which was and we're actually executing on that vision in a serious way. It was more of an aspiration, I think, when I joined, but now we're full on executing
What's
on that
interesting,
vision.
I mean, I remember you saying that to me,
Yeah,
I want to say last JP Morgan, when we were
yeah,
actually able to travel and
yeah.
sit down with each other. But um, do you think that, I mean, I talk to other people and I mention Tempus and some people go, who?
Yeah. Oh, yeah. Yeah.
And other people who are very knowledgeable
Mhm.
are
Yep.
like, well, I don't see what the big deal is. And
Yep.
so it almost seems like, do you think people know what's there that they can take advantage of?
I don't think people fully appreciate it. And there's, of course, there's a bunch of things I can't even talk about that are even more exciting that are being cooked up. But or you'll be hear about them soon. I think we'll make a few JP Morgan announcements. But um, it's sort of the MO. Actually, one of the things that attracted me to Tempus was our CEO is very much a show don't tell kind of guy,
Right.
and it to the point where even some people get frustrated because nobody gets frustrated, but it's like, hey, we're doing all these amazing things and nobody knows about them yet. But he's 100% right in that, like, people will know when we're actually doing once we're doing this stuff, right? And that was impressive to me because we're obviously in an area that's so overhyped, precision medicine, AI in medicine, and there's a gazillion companies out there doing proof by press release, on all their
Yeah.
vaporware, and Tempus is doing real stuff that's saving patients' lives, and they're being very disciplined about it and not overhyping it and just putting in the work, and then in the long run, people will know, what Tempus is. I think it's going to be all one of those things like, who's Tempus? Or like, oh my God, I had no idea. Like, where did this come from? This is
Yeah,
insane.
I think your
So
biggest challenge is going to be the last mile, right? I mean,
yeah,
it's like internet connectivity, right? Well, it's on the street,
yeah,
but how do you get it into the house? And the
yeah.
biggest
Well, I
complaint
would.
I always hear from everybody is getting this implemented at an institution is not trivial.
I would argue that's what Tempus is mainly solving, is that last mile problem. In fact, we're I don't know how many institutions are connected into Tempus, but it's well over 100 for sure, and that's a KPI that we're tracking. How many institutions do we have last mile connectivity into, and that's been just growing up. That was a huge KPI for us last year, and it continues to be. But I would argue that's the problem Tempus is solving, is that last mile, because we are in clinic, in EHRs, have bidirectional data feeds and clinical decision support, and a large number of institutions. It's just people don't realize it yet. So
Well, let me ask you to, I don't even know if you're still doing this. You were part of the Institute for Next Generation Healthcare. I don't know if you're
yeah,
still,
no, not anymore.
okay.
Sure,
Well, so I'm trying to get you to put your next generation hat
sure,
on here
sure,
for a
sure.
second.
Mm-hmm.
And if you're looking at everything that's going on and where this is going, like,
Mm-hmm.
where do you see the next big, leaps coming? Where do you see
Mm-hmm.
the next changes coming and how we're going to make a difference for patients and hopefully bring down cost? And, how is the technology that you guys are working on, or where
Mm-hmm.
you see it going, sort of driving that next level of outcome for patients?
Yeah, I mean, Like, what we always like to say at Tempus is we don't know, because which actually it's a very Tempus-y thing to be humble that way, because we don't know. Like, well, all we know is that we have to build this data set, and we need to build these pipes, and we need to, like, because that will enable whatever the thing is that hits is the next big thing. I mean, clearly, like in cancer and other areas, we've got some clear value propositions, and in starting in cardio and neuropsych. But I'm convinced if Eric was on this podcast, the first thing he would say is, I don't know, we don't know. But we do know that it's going to require huge amounts of data, and we're going to collect that data, and then hope either we figure it out or someone we work with figures out what the next big thing is. But if I put in my personal hat, I guess, I've always been interested in prevention. It's not an area we work in at Tempus a lot. We work with a lot of late stage disease. Obviously, when you start in cancer, you're starting in some pretty heavy disease area, right? And life and death. But we are getting into cardiology, and we're looking at endocrinology and diabetes. We have a big diabetes effort that will be announced soon. And so I think when the stuff we're doing in cancer, or this approaches we're building at Tempus, start to be applied to prevention, I think will be really interesting in terms of moving the needle. And then, and it could, post-COVID, we'll see what happens with telemedicine. But right now, we primarily interface with, and again, I'm speaking personally, I'm not divulging any strategic roadmap or anything here, but I would imagine at some point, if telemedicine continues to go the way it's going, there's no reason a purely virtual telemedicine company couldn't plug into Tempus in the same way an academic medical center does, right? So, which I think would be enabling.
Well, I would hope that would be. I mean, if you think about the CVS Aetna deal,
correct? Yeah.
That I know CVS last year. You guys announced a deal with CVS, if I remember correctly.
Mm-hmm, correct. Yeah.
And so I think now that telemedicine has become much more, the way to do things. Why would you want somebody going to the ivory tower when you could plug them in through the system and interact with them there? And I mean, there's a huge cost savings, and from a time standpoint, it's just more efficient.
Yeah. And we spoke with a institution, which I don't think I can name at this point, but they had mentioned that during COVID, they had even spun up a tele-oncology practice, which was surprising to me, because oncology is just one of the things where you think, well, it's so complicated, you can't, spin up a tele-oncology service. But in fact, they had, and it did extremely well over COVID. And then when you start to think about oncology, well, it's like, okay, I mean, you got to see your doctor, but then they're saying, well, go get your labs at Quest.
Right.
Go get your infusion at the infusion clinic. It's not like you have to stay in the doctor's office. So then I started thinking about it. I'm like, oh yeah, tele-oncology can work. So whether we'll see broad expansion of tele-oncology, probably after people see the profits this AMC made, or not AMC, it was another health system. But so it could be even in oncology, we see totally virtual services, plugging into something like Tempus.
That would be interesting. I always think, like, I'm getting older, so the faster that we move into this new world, I'm the happier that I will have a better experience, right?
Absolutely.
So, well, I feel like, knowing the two of us, we could probably talk about this for hours, right? Especially on the data side. I think you're right. There's an underappreciation for where, once you have the data, what the different things you can do with it over time.
Yes.
It's more like that from the science as opposed to the data side of things.
Yeah. And I think a lot of people who practice, data science and machine learning know this. It's just huge amounts of data, of high quality data, just trump any, sophisticated machine learning method. What I mean is, like, choosing between, like, the latest, greatest, deep learning or whatever method versus just having a simpler method with huge amounts of high quality part being important data. I would take huge amounts of high quality data any day, because that's way more enabling than whatever sexy, machine learning method is. And it's usually the case that once you have vast amounts of high quality data, fairly straightforward statistical, modeling, methods will yield just amazing insights that come as a virtue of the scale of that and the quality of that data. And I think that's what, the lesson I've learned at Tempus is that just data just trumps all, and from that perspective. And I think it's important to point out, because if you're because there's a lot of tool only companies in this field, right? They're like, oh,
Right.
no, trust me, this deep learning is better than that deep learning method, or it's got this little extra thing, or this topological method is better than deep learning, or it's just like, who cares? It's like once you have the volume of data that we have.
Yeah, I the only place where I would not differ, but say, I think when you've got multiple high quality data sets, then you need a little bit of help making sense of it all, because the human brain was not designed to look at multiple pieces of data coming together and see patterns that it might not normally be able to sort of visualize.
No, that's absolutely true, and that's I'm probably being oversimplifying that, because that's my career has been multi-scale data. It's like machine learning and stuff like that. So I feel like I should yeah, that's a good point. But huge amounts of high quality data, and this multimodal, we always say multimodal aspect is really important, because you want different high dimensional measures on the same sample or same individual, if you will. And obviously longitudinal as a dimension is a very powerful dimension as well.
Yep. So. Yep. No, well, this is something like, I talk to people about, and Joel, not to sort of build you up, but I mean, there's not many people that have the biological and the data background in one. We haven't, I don't believe we've graduated enough of them yet.
Yeah,
we're moving in that direction, but not enough of them yet. So it was great to have you on the show. Let's I'm hoping that we'll actually get together sooner physically rather than later. But I have a feeling we're in this for another 4 or 5 more months. Before this thing starts dying down.
I probably when we'll travel back. But it's wild though. I was thinking, like I said, maybe I mentioned this last time. I've been only at Tempus only like a year and a half, and we've added $5 billion of valuation in that time. But what's really cool about that is not that we're worth $8 billion in valuation, because valuations are, whatever. But is that there's a sense within Tempus that we are still a small, scrappy startup just getting started. So like that's my favorite part about that number, is not that, because I think a lot of companies, if they had an $8 billion valuation, they'd be like, we made it. This is great. But Tempus is like, just completely ignore that. We are just getting started. Like it doesn't matter to anything we do day to day.
Well, I remember when I was at Applied Biosystems, the valuation was going off the chart because we were doing the genome, and couldn't install machines fast enough. And I remember talking to some of the senior people and saying, okay, well, what are we going to do next? And I remember the gentleman who was way taller than me, looking down at me and said, have you seen our stock price? Like, we're killing it. We're performing admirably. And I remember going home and telling my wife, like, I think it's time to sell some stock, because that is not the right mindset for success.
Not the right mindset. No. Yeah, it's very refreshing. That that attitude is just, across the board at Tempus, everybody's like, we're just getting started. Heads down, keep cranking. And we really, obviously comes from leadership, but we really block out any distraction that would come from that type of valuation or whatever. So it's really fantastic leadership on the part of Tempus.
Well, one of these days, I hope to meet Eric. He sounds like an interesting character. But stay safe, stay healthy, and
you too.
Well, obviously you and I will constantly continue the conversation in the background, but it's great to have you back on the show. And honestly, huge change from Mount Sinai. I never
Yeah,
thought you would leave that place considering.
I never thought either. But yeah, I enjoy it. It's been yeah, like I said, as I've been recruiting people, I said you got to get, like, I don't care how good your job is now, you got to get out now. There's this wave everybody's gonna be riding in the next decade that you're very well. If I talk to someone like me, you're so well positioned to do it, and you're gonna, if you don't get out and just try, you're gonna kick yourself in 5 to 10 years and say, I saw this coming, I saw this big thing coming, and I didn't get out. So
Well, I've been
yeah,
saying, since
yeah,
we were doing the genome, I remember telling all my friends, I'm like, biology, man, biology, and
yeah,
where the data is going is where it's going to be. And people were like, well, tell me specifically where to put my money. I'm like, look, I can't tell you right now specifically. I'm just telling you that that whole area is going to explode. And I think it's just going to, I mean, now we're at a point where the curve is ridiculous.
yeah,
Gene editing
yeah,
stocks, what's happening in the space. I mean,
yeah,
COVID has pulled stuff forward in a way that I could never have imagined.
yeah. Me either. Yeah, yeah. It's a huge catalyst. I agree. So
So,
it's amazing. Good time to be in the field for sure.
oh,
Yeah,
best job in the world. I always tell people.
yeah, yeah. Science fiction and
So,
cool business,
oh
basically.
yeah,
So
yeah, yeah, yeah. You got to have a little bit of both, otherwise it gets
yeah,
boring.
yeah, exactly. Awesome, man.
All right.
Well,
Well, uh, good to talk, and
yep.
we'll stay in touch.
All right. Sounds good. Take care, man.
All
Good
right.
to see you. Yeah. Bye.